Alrighty, so what we're going to do now is we're going to work backwards from the previous video. Now we are looking to graph f if we are given f prime. So if we're given a graph for f prime of x, the derivative, understand that we are given a graph of all of the slopes of the function. Okay, all the slopes of the tangent lines. And the basic idea here is we need to draw a graph for f of x that's going to have those slopes. So if we take a look at our given graph for the derivative, f prime of x, notice that this piece down below here, for x values less than 1, it has a slope of -1. Because you can see there that it is below the x-axis, the slope has to take on values for -1. And likewise for this piece up above, our slope is going to be 2 when we transfer it over to f of x. Okay, so the f prime of x graph, and notice how I labeled the axes. We have x and then y prime. Okay, it's tempting to think, well, hang on, these are horizontal lines, how come the slope isn't 0? Well, this is a graph of the derivative. So if you were to look at the slope of this piece here, well, now you're talking about the second derivative, okay, the slope of the slope. So here we're just reading the slope values for f prime of x. So what this is telling us to do, if we start down here for x values less than 1, we know the slope needs to be -1. So if we were to draw something, and there's going to be several possible graphs here. So here is my x value of 1. So to the left of that, I need to draw something that has a slope of -1. Now, we don't have any information telling us what the y-intercept is supposed to be. We don't know any points that it's supposed to pass through. So again, there's a lot of different ways you can draw this. Okay. Let's suppose we want it to go through the origin. Okay. So if we want it to go through the origin with a slope of -1, it would come down and stop right there at 1. And then from there, when x is greater than 1, we know the slope needs to be 2. Now let's assume we want this function to be continuous. So from there, it would turn and go up. Okay, so we'll make that continuous. Notice that it's a little bit steeper, so I'm going to label here that the slope here is 2. Over on this side, the slope is -1. Okay, so we'll talk about this more in videos to come, but notice how back over here at x equals 1, it's not included. Okay, you see two open circles, so that is showing us that f prime of 1 does not exist. Okay, so we don't see a closed circle, so according to our graph here, f prime of 1 does not exist. So that doesn't mean f of 1 doesn't exist. Okay, f of 1 does exist. Okay, but what we have here in this scenario is a sharp turn. Okay, in this possible graph here, we have a sharp turn, and like we'll discuss in a video coming up shortly, if you have a sharp turn like that, a derivative is not going to exist. Okay, so the idea here is that you can have f prime of 1 not exist, okay, but f of 1 can exist. Okay, so this is working backwards. If we're given a derivative, looking to graph f of x, again, just need to pay attention to what the slope values are and then draw portions of a curve that will give you those slopes.